Hey everybody, I just had a real crazy idea. I'm watching this video, this guy talking about Moana, and I just had this really weird thought. Alright, you know how some people say that we evolved from fish and all that, right? And then went from fish to mammals and this and that and this and that. How the fuck did how did creatures come out of salt water and get on land and know to drink non-salt water? That doesn't make any fucking sense, does it?
Oh my god, he's still alive! Hey guys, welcome back to my channel. This is Time Shark. Today I'm looking at Evolution is a Lie, and here's the proof by a guy whose name I cannot pronounce. Go look at his original video, I'll link it in the description. Godless Engineer also did a response to this guy. He's actually the reason I spotted this video. So I'll link his video response in the description as well. Go check that out too. Now, Godless Engineer did a really good job on his, but biology is my background, specifically marine biology, so I think I can kind of add a little bit to the questions that this guy was having, maybe clear some things up. Before I bore you to science, let's go with why this guy is completely wrong. His premise, evolution is a lie, and here is the proof. He does not offer any proof or any reasoning other than, I don't know, therefore it's not right. It's an argument from personal incredulity, and that's pretty much the end of it. You can't make proof out of a logical fallacy. Now that that's out of the way, on to the video and to the science.
You can't sit here and tell me, and it's weird, I just really thought about this. It just blew my mind.
Obviously.
If creatures came from the salt water, right, and they went on the land, do they, you would have to theoretically at first, I guess, go back into the ocean to get your food.
Not necessarily. Before tetrapods got on the land, which is I'm assuming that's what he's talking about. He talks about birds and reptiles and stuff and fish later. Before we got on land, there were already arthropods and early insects and a lot of plants. For some context, we're talking about the Devonian period of Earth's history, also known as the Age of Fishes, which makes it one of my favorite ages. Now, the Devonian period, which is between 417 and 354 million years ago, give or take, was characterized by nice warm tropical temperatures, the first complex land plants, arthropods being all over the place, and the first land vertebrates. That would be the tetrapods. Alright, now the land didn't have a huge amount of life on it. Lots and lots of plants and some early arthropods. And they would have diversified pretty quickly because there were a lot of niches to fill. But the water was full of life. There was not a speck of water, fresh or salt, that didn't have something in it, most likely. Lots of arthropods, various different sizes. Lots of the first fish came up at this time period too. Bony fish, cartilaginous fish like sharks, and then the lobed fin fish, which are the focus really. That's going to be the early tetrapods came from. Now the earliest tetrapods were going to be these lobed fin fish, and then we get into amphibians, which are going to be very similar to a salamander type thing, but think a lot bigger. So as far as food goes, the early tetrapods are really spoiled for choice. They could go into water or out of water to find food, and they could eat arthropods, plants, fish, smaller tetrapods. Pretty much anything they could fit in their mouths, really. Now, these things are on the menu as well. There were a lot of different large fish, some early sharks that could live in fresh water, and then a lot of these arthropods would eat them too, like the big sea scorpions I had on the screen earlier. There's also something else I want to point out with this. It probably happened in freshwater, not saltwater. Amphibian physiology works a lot better and is a lot easier to deal with in freshwater instead of saltwater. I'll get into the whys a little later, but it's just something I wanted to point out for now.
Because if, go through evolution, there really shouldn't be any really sort of food for the creatures on the land. Now, yeah, there's creatures that are in the water that eat birds and, stuff like that. I can understand that.
There were no birds. There were no birds in the sky for hundreds of millions of years. The food was fish, invertebrates, and plants. That's all. In water and out of water, same.
But I'm really talking about, think far back, like they say that. Before there were birds, there were fish. And then somehow, theoretically, the fish that was on land somehow developed wings to fly. You know, they say this kind of shit, right?
No birds, just fish. Fish did not develop into birds. Birds came from dinosaurs, which came from early reptiles, which came from amphibians, which then came from fish. I don't know what's his obsession with birds.
How the fuck can you go from being in a saltwater pool to knowing you have to drink fresh water to live?
They probably didn't. They probably went from a freshwater pool to living on land and somewhat in fresh water to living predominantly on land and then drinking water. It's more than one step. That's the big problem here.
It doesn't make sense. Why do we as humans, we cannot at all drink salt water and live?
Yes, we can. We just can't drink only salt water because it'll dehydrate us. I believe it's time for science tangent number 2. Now, the whole issue with drinking fresh water versus salt water, and as far as humans and other animals go, is that it's an issue of diffusion and homeostasis. Now, homeostasis in biology refers to the tendency of an organism to maintain stable internal conditions regardless of the external conditions, and diffusion is simply the movement of particles or other substances across membranes, generally, at least in our context. Now, we're specifically talking about water, so osmoregulation is the context. Now, osmoregulation is pretty much just keeping the amount of water, or the concentration of water to salts, constant. It's a very oversimplified version of it, but there you go. Now, in saltwater fish, they have an issue that the salts in the water outside their body will actually pull the water from their body tissues. In freshwater fish, they have the opposite problem. They have higher salt content inside their bodies than outside, so the water from outside will rush in and their salts will be pulled out. If you ever put a freshwater fish in salt water, you will actually see their body tissues start to shrivel slightly as the water gets pulled out. And if you put a saltwater fish in freshwater for too long, you'll see their bodies start to expand, especially some of their softer tissues. I don't recommend doing that. Just take my word for it. Please do not torture your goldfish. Okay, now that we've had our little science tangent, let's check out the video some more.
You cannot drink that shit and live. It's impossible.
I almost forgot. When it comes to land animals drinking salt water, it's a similar problem to when freshwater fish go into salt water. Our internal system is going to be less salty than the water we're taking in, so water will be pulled out of our system into our stomachs to dilute that salt water. Now, there are plenty of animals that can drink salt water, and the way they get around this is either to store the salt in a different organ and have it excreted later, or to just shoot it out almost directly. You'll see a lot of like marine iguanas, they drink salt water, and they end up squirting salt crystals out of their nose, little by little. Same thing happens with a lot of sea turtles, things along those lines. Some animals do a different approach. Sharks, especially bull sharks, they will actually increase the concentration of other chemicals in their body to offset the different levels of salt. I think a lot of times sharks will use things along the lines of ammonia. Now, because the concentration of urea, I believe is the form of ammonia they use, is higher in their bodies, it will keep the salt from diffusing across membranes. Same kind of idea. The water can only hold so much chemicals of any type, so having something else in there blocks the salt. Humans couldn't do that. We can't survive with that level of urea in our systems.
How can a creature evolve out of water to drink fresh water? That's the question I'm asking.
Oh, so that's the question you're asking. Oh, and by the way, in case anyone's interested, I cut out a lot to get to this point. Simple answer is, just about every animal can drink fresh water. Even animals that live in salt water their entire lives are perfectly capable of drinking fresh water if it's available, especially things along the lines of amphibians, reptiles, and mammals. A seal or sea lion will live in salt water their entire lives. They will happily drink out of a freshwater puddle if it's available. For a saltwater animal, their issue is not having too much water, it's not having enough water. Their system is constantly having water pulled out, so they will perfectly happily take any fresh water that's available. I don't really know of any special adaptations for any animal as far as to be able to drink fresh water. Drinking salt water can be an issue, but drinking fresh water All they do if they get too much is excrete some of the extra.
Now there is this thing I seen in the ocean, and it was pretty fucking cool. It was where the salt water met the fresh water, right? So are you going to tell me that even then, so there were creatures that were in the salt water that went over to the fresh water and was like, oh yeah, I can breathe and drink this shit?
Transitioning from salt to fresh really isn't that easy. And there's a lot of different animals that can do it, and they each have slightly different adaptations for it. I mentioned sharks a little earlier when they adjust their body's internal chemistry using urea in order to osmoregulate and keep the salt from flooding in or the fresh water from flooding in, depending on where they're headed. Other animals deal with it simply by being less permeable, having thicker skins, and keeping the water inside or keeping the salt inside, or vice versa, depending on which direction they're headed. And then also adjust anything that gets in too much by excreting it out using urine or feces. This is kind of what mammals and reptiles do, and birds, because our skins are thick enough to block the water. For amphibians and fish, it's a little bit tougher. For fish, their gills are their weak link. Water can go back and forth across their gill membranes extraordinarily easily. For amphibians, it's their entire skin that lets water in and out and salt in and out very easily. So for fish and amphibians, it's all about their excretory systems. I can never say that right. Now, for freshwater fish, they're constantly getting in too much water, so they're trying to pee it out, for lack of a better phrase. And in saltwater fish, they're constantly getting not enough water, so they're trying to hold it all in and get rid of as much salt as they can. For amphibians, the problem's about the same in truth. They have to excrete water if they're in fresh water, and then keep it in if they're in salt water and excrete the salt. Amphibians really don't do that very well as far as the saltwater side of it, at least not amphibians from nowadays. So it ends up being a big problem. But we do have lots of examples of animals that can go back and forth, and they do it simply by changing the osmoregulatory system slightly.
When they tell you you can't take a saltwater creature and put it in fresh water because it'll die, and you can't take a freshwater creature and put it in salt water because it will die, what the fuck does that mean? That it really doesn't make sense. Does it to y'all? I'm just wondering, really.
It makes pretty good sense to me, although it is hard to explain. It's all back to that osmoregulation thing and the diffusion of water across the membranes, or salts across the membranes. It's a matter of keeping the balance. I think I mentioned it a little bit in depth earlier, so I'm not going to go through it again.
That's like, what do they call it? Reverse osmosis? But you can't pull a reverse osmosis from not accepting to accepting. You know, like...
Now, I'm sure he's heard reverse osmosis in regards to filtration systems for water. A lot of the bottled water that we can get in stores has been filtered using a reverse osmosis system. It pretty much just means that we're pushing the ions against the gradient. Instead of letting them flow from high to low, we're pushing them from low up into high to get almost nothing in the output and leaving all the ions somewhere else, usually stuck in the membrane. The systems that we use for bottled water are actually super advanced, but each animal has a very similar system that's in our excretory system. That's how our urine can have such high salt content that it's toxic to us, even though our blood's nowhere near that. The exact mechanism to achieve that can vary by organisms. It can be something as simpler as a cross-current flow or counter-current flow to things like ion pumps and cellular membranes. Alright, now, his video goes on for a little longer, but he just repeats himself and talks about poison and things along those lines. It's nothing else that has anything to do with the topic that he originally brings up. So I'm just going to end it there. If you guys want more information, feel free to ask me. I'll see what I can put together. Also, you can check out Aaron Raw's channel. He does a lot with this style of thing. A lot of evolutionary science there. So thank you for joining me, and have fun. Later.